Good afternoon. My name is Austin Harris, and I'm going to be walking us through an Eagle by Autodesk tutorial today. A great thing about Eagle is that there are a lot of online resources available for people that want to learn it, and so that's what I did to learn over the past 2 weeks. And so I encourage you to go find tutorials, go find forums, and just get some practice. So the tutorial we're going to be following today is Schematic Basics, Part 1 through 3, and PCB Layout Basics, Parts 1 through 3. Those are on the Autodesk website, so you can just Google those and find those. But we're going to begin by opening up Eagle. Which is going to take us to the control panel. And so this is going to be kind of our base for our project today. So our project is going to be a simple LED flasher circuit. And so anytime you want to begin a new project, you go down into this menu and select projects, and in this subfolder projects, right click and select new project. And you can just name your project whatever you want. We'll just go with Eagle Tutorial. So now that we have a new project started, we want to begin the first step in our design for our LED flasher. And so that is going to be creating a schematic. And so to do that, we're going to right click on our project and move over to New and select Schematic, which is going to open up a new window and give us a schematic workspace to begin adding parts to. And so kind of the big hurdle in designing an Eagle is getting all of your components added in correctly. And so to do that, you want to go over to this Add Part button. And so that's going to take you to a window with several different options. These are called libraries, and so they each have a lot of different parts, electrical components that you can select within each of them. So the tutorial we're doing today shouldn't need any other libraries than what's already added into Eagle, but there are a lot of libraries that you can use that might not necessarily be activated. So for example, sparkfun is a really popular library set that people designing electrical parts with Arduino and Raspberry Pis will use. And so say for instance we wanted to add in the sparkfun LED library. We could go over to Open Library Manager and go over to the Available tab and type in sparkfun-LED, and this gives us the sparkfun LED library. And so if we want to be able to use the components within this library, we select it and click Use, and now it's available for us to use in our schematic. But we'll go ahead and exit out of this because I don't think we should need it. So for the parts that we do need today, first part we're going to need is a timer. And so to add in a part, you can use this search bar, and our timer is going to be an NE555. And so you search for that, and it pulls it right up. So in this microelectronics library, we have the part NE555. And so you can see over here on the right, it gives a description. It gives the schematic representation and the PCB representation that we're going to use later. So to add in this part, we are going to double click NE555, and you can see it pulls out that schematic representation, and it allows me to place it in our schematic workspace. So we just need one of these, so I'm going to click once and it leaves it right there. And so I could add in multiple if I keep clicking, but since we only need one, I'm going to do Control Z and just stick with a 1. But we'll do that for all the parts we need. We need this timer, we need 4 resistors, we need 2 LEDs, a capacitor, and a connector. And so we'll add in all those parts. All right, so all of our parts are added in. So like I said, we have our timer, our 4 resistors, a capacitor, 2 LEDs, and our connector. So one thing I forgot to mention was that when you are adding in parts, the search is very specific, and so you just want to be careful while you're searching. You can play around with putting asterisks around your search, and that might pull up some different parts, but you just want to try several different things while you're searching if you can't find a specific component that you need. But now that we have all of our components added in for our schematic, we are good to lay them out in a way that allows us to lay out the schematic. And you just want to put them together in a way that makes sense to you and allows you to understand what the circuit is supposed to be doing. So to move any of these components, what you want to do is go over to this move button and place your cursor over the cross of the component. And so you can see this connector has a cross right there. A resistor has its cross right in the middle. The LED is right there. So to move something around, you place your cursor over that cross and click, and then it turns a different brighter red, and you can move it around. So like I said, you just want to do this in a way that makes sense to you. It can also be helpful to take components and rotate them. And so for instance, I'm going to take these resistors and I'm going to rotate them. So I can either use this rotate button and just click right on that cross again, and it'll rotate at 90 degrees at a time. Or when I'm in this move setting, I can click and then use a right click to rotate it 90 degrees at a time while I'm moving it. So that's what I like to do. So I'm going to let these be vertical, and we're going to get all these components moved around. So now all of our components are laid out in a way that's going to be great for designing this schematic. So the next thing to do is connect all of our components. And so the way you do that is you go over to this net button and you select it. And as you go over each component, you'll see has these green circles that pop up. And so these are nodes where you want to connect your nets to. And so what you'll do is you'll click on one node and drag it to where you would like for it to go, and click again. And so now you can see that I've established a connection between our connector and the first LED. And so we will continue doing that. And one thing I do want to point out is there are junctions and there are overlaps in when you're making these connections. So a junction is when I take my net, say from pin 3, and I tie it into this net right here. And so I can tell that I've made a junction by this green circle right there. And so I know that pin 3 is connected to this net right here. An overlap would be, say, if I just take pin 4 and I draw a net out here. So I can tell that these aren't connected because there is no green circle right here. So that's good if I'm trying to just it's good to know if I don't want things connected, and it's good to know if I do want things connected. So that's not where I want pin 4 to go, but we are just going to continue connecting our components. So I have now all of my components connected correctly. I can tell that I have junctions where I want junctions and overlaps where I don't want junctions. So you can see junction right here, but not a junction where 7 is crossing over this net right here. So just something you want to be careful of. So now that all of my components are connected the way I want them to be, now I can go in and add different values to the components that I do have. So if I click on this value button and say go over to resistor 1, I can add in a value just to make it easier for me to reference. And so I'm going to put in 1K for resistor 1. And I can go over to resistor 2 and do the same thing, but I'm going to do 470K, right? And so I can do this with all the different components, and this will just help me to keep everything straight. So now my schematic is connected and labeled correctly, and the last thing that I want to do before I actually put this to be a printed circuit board design is I want to do an electrical rule check, and this will just help me to see if there are any errors, anything that I didn't connect correctly or left out. And so you can actually see I left pin 5 unconnected, so to intentionally throw an error. So if we go and click on the electrical rule check button down here in the bottom left, it runs the check, and you can see it gave us a few different errors, or I guess 1 error and 5 warnings. So errors are a big red flag, and so that means something is wrong with your schematic. And for this, you can see it says unconnected input pin on IC1, and so this IC1 is this timer, and it's on the CON pin. So it's saying that pin 5 is unconnected, and so that's something that I need to fix. So to fix that, we need to add in another capacitor and connect it to this net down here. So we are going to go to add part, type in electrolytic capacitor, and select this first one. And we'll just go ahead and place it right there. And we'll do our net just like we did earlier. And you can see we got our junction correct. And we're going to put a value on this capacitor. Okay, so this error should be resolved now. So if we run this electrical rule check again, you can see that we have no more errors, and we're just left with these warnings. So the warnings are not as big of a deal as an error. You still want to check them out and make sure that nothing is really wrong with your schematic, but certain things like these two are just saying that the net that we've connected the ground pin to and the VCC pin to are labeled incorrectly. So if we go over to name and I change this, I click on that net and change it to VCC plus, and put that label right there and run my electrical rule check again, you can see that warning disappears. And so it's the same thing for this this ground pin. I'll go ahead and change that. So now you can see I've gotten rid of those 2 warnings, and these other 3 are just as a result of me not having values associated with my LEDs or my connector. And so, like I said, this isn't really a big deal, but I could fix this by just assigning values. So we'll do red for the LEDs, and we'll do 9 volt for our connector. And we'll run the electrical rule check again. And when there are no errors, the box does not come up, and you can see down at the bottom left it says no errors / warnings. And so this lets us know that our schematic is good to go over to our the PCB design. Right, so now that my schematic has been finished, I am ready to take this over to the PCB designer. And so to do that, I am going to go to this button, and I'm going to click it, and it's going to ask if I want to make a schematic from, or make a PCB design from the schematic, and I'm going to select yes. And so now I have on my left, I have all the components from my schematic, and you might recognize some of these representations from when we added in the components in the parts description. And so on this right, this darker box is our PCB board. And so we are going to drag and arrange all of these components onto this board. And this is where we're going to lay out our traces, and this is actually what's going to be manufactured. So when you're designing your board, it's a balance of getting it as small as possible for cost reasons, because usually it's the smaller the board, the cheaper, but still leaving enough room for you to get all of your traces that you need to get in. So we are going to start dragging our components in. So there's one important thing to note is that there is no right or wrong way to lay out a circuit board. It is pretty much an art, and so whatever makes sense to you is good. Obviously, there's some ways that are better than others, some ways that are going to be cheaper than others, but that's just important to know that there's not necessarily a right way to do this. So a lot of times people will start with their biggest components and work around those, or start with if their board has any connections that need to be made on the outside edge, they'll put those components there first. It's really just up to you. So I want to start by placing my capacitors, and so I move these components around much in the same way that I move them around in the schematic. And so there's a cross in the middle of these components, and that's what I'm going to click and drag. And you can notice as I'm dragging these components, I have these yellow lines that are following. And so these are air wires, and they represent the electrical connections that we built in the schematic. And so you can see the capacitor right here is connected to different pins in our timer right here. So you can see they follow each other. And so these can obviously get really messy. So every so often when you're placing components, you want to click this rat's nest button, and that will reroute your air wires and just kind of help you to keep things as clean as possible. You can also rotate your components just like you did in the schematic. So I'm going to try and rotate this timer just to help my layout. So I'll place these right here. So we're going to get all these components placed. So now that we have all of our components laid out in a pretty tight layout, we can go ahead and route our traces. And so our traces are the connections that are represented by these yellow air wires. And so for a small and simple board like our LED flasher, we can actually have a pretty good bit of success with the auto router. And so I just want to show you that really quick. So this is the auto router button over here. You click that. I said this is pretty small, so we can set the effort level to low and go ahead and go with continue. And so that will take us to this screen, and we can hit start, and it will, because this is such a simple circuit, it should get up to 100% pretty quickly. And so you can see it laid out some red and blue lines that are replacing those yellow lines. So one of the great things about circuit boards is that most of them are two layered, so you can actually have traces on the top of the circuit board and on the bottom. And so for Eagle, the red is on the top and the blue is on the bottom. So that's what allows these to this board to look like it's having intersecting traces, but you don't see any reds crossing over each other or any blues crossing over each other. But anyways, that's the auto route. Like I said, for a simple circuit like this, you can actually be pretty successful with that. But the more complicated you get, the harder time you're going to have with the auto router, and probably the less success you have. So it's important to know how to do your own routing. So if we just undo that, we can go over to the manual route button, which is right here. So click on that, and you can start replacing these air wires with routes. And so you click on the part that you want to, where you want to lay down your trace, and you can see I replaced that yellow air wire that was right there with a red trace. And so you can do these for all the different parts, and this is something that you're just going to have to play around with. But I can switch between laying down red traces to laying down a blue trace by hitting the space bar. And so now I'm connecting on the bottom of the board. So anyways, this is really nice. It's actually pretty neat how it will route your traces. And so this is where you get to be creative and figure out the best way to route your board. One other useful tool while you are routing your traces to be aware of is the use of a via. A via is basically a through hole that allows you to connect a top trace to a bottom trace, or vice versa. So say I want to get a trace to go from here to this pin, from this resistor to this pin, and I'm using the top trace. You can see while it does allow me to route around my current traces, I also have the option to, while I'm in the middle of routing this trace, to hit the space bar, and that puts a green circle around my trace, which represents a via. And so if I click, that places the via and switches my red trace to a blue trace, which allows me a little bit more direct path to my pin. So that's just a good thing to be aware of if you have a if you're trying to connect a pin that is surrounded. It allows you to be able to switch from the top to bottom trace pretty easily. So now that I have my components and my traces laid out, the final step that I'm going to show today is doing the design rule check, which is similar to our electrical rule check that we did for the schematic, but it's just going to make sure that we don't have any errors in our PCB design. So I'm going to click this down arrow and click the DRC button. And so I can go through these different tabs and mess with the settings to refine my check, but I'm just going to leave it as is right now. So I click check, and it's going to throw an error. And if I click on the error, it'll take me to where that's taking place. So I did not connect resistor 4 to LED 2. And so I just need to add in a trace and you can see that resolved the error. So I can run it again just to be sure. But that window disappears, and you can see in the bottom left it says I have no errors. So so I can feel good about this design. Now there are a lot of other things that I can keep doing to make this board look more professional. I could do copper pour, or I could add a silk screen to label different pins and stuff. But just for basics, this is good to go. So from this point on, you would need to get your files in order to be sent out to a website like PCBWay to get this board actually manufactured.